Hi everybody, this is Morgan here with Positive Approach to Math. Thank you for following along in our functions topic of Algebra 1. We are moving right along with lesson 6. So first let's talk about what function notation is. We're going to dive right into it. You should know the drill. If you need any support, check the details below. I have a blank PDF of this notes packet. I also have some utry keys and I have a video linking to the utry. So talking right away what function notation is it is the big kid way I try to describe as talking about that ordered pair x comma y, right? It's a way to represent an equation as a function, okay? Instead, so we're used to seeing x comma y in everything we do, right? Up until this point. But we're going to talk a little bit about how we can change that up and make it a little more sophisticated. So what we do is we still keep x our x, and we still want to recognize x is our input, it is our domain, it's all of those good things. It's our independent variable, so on and so forth. Our y is still our output, it is our range, all those good things. But we're going to change it to a little bit of a different notation. So I like to teach it as for Halloween, you get dressed up, but underneath your costume, it's still you, right? And that's what this function notation is. In place of y, we're going to use f of x, a new way to represent y. It is still y, it is still your output, it is still your range. It's just dressed up in a Halloween costume, but underneath all that fancy f of x business, it's still just y underneath. So instead of seeing x comma y, right, you're going to see some new notation, x comma f of x. And that f of x is representing that y. It's really, I always say, y in disguise, right? And so it's still your input. The only nice thing about f of x is you can use this notation to see what the input value is in that statement. So if I say f of 3, I see, oh, 3 is my input, and I can calculate then when 3 is my input, what will my output be, okay? So when we give you a specific input value, we can evaluate functions by substituting the input in for x and using our simplifying expressions property, ultimately PEMDAS, to simplify it down to a singular number. That number we get is our output. It is our f of x. It's saying if I had a graph of this function, this ordered pair, input comma output, would lie on my graph. So what we're looking at, we're going to jump right into our examples. What we're looking at here is we have the example f of x. Remember, f of x is really just y in disguise. And it's saying that it's equal to negative 3x plus 5. It's asking us to find each value. So what we're doing ultimately is I'm going to dive right into it with an example and explain that process. If we look at f of 2, letter A, they're telling us that 2 is our input. It is our quote-unquote x, okay? And so what we're going to do is wherever we see an x, I like to call it function machine, in our function machine, we're going to pull out that x and throw our input of 2 in for it. So what this is going to look like is we're going to say, okay, f of 2 equals, and then we keep that negative 3. We're substituting in 2 for x, and that's going to be glued together with multiplication, and then we copy everything else down plus 5. And then from there, we're just simplifying that expression on the right. Negative 3 times 2 gives us negative 6. Negative 6 plus 5 gives us negative 1. So that is our output. So what we have is that f of 2 equals negative 1. Or we could say, okay, when our input is 2, when our x is 2, our y, which is f of 2, would be, I don't know how it did that, would be negative 1. So that's like your x, and that's like your f of x or your y. And so all you're doing is you're plugging that thing in that parentheses. That's your x. You're substituting it in to that function machine, and then you're going to evaluate it. And we can make this more complicated, and in fact, you will make it more complicated as you move to Algebra 2 and pre-calculus. But let's keep it where we're at for now. So looking at letter B, it wants us to evaluate f of -1. So that says we're going to look at our f of x function, and wherever we see an x, we're going to take that x out, and we're going to substitute in -1. Okay, so I used the same function. I'm using this for all three problems. And all I did was I took that x out, and I substituted in -1. Same process. Now we're going to multiply -3 times -1, which will give us 3, and then bring down that plus 5. And 3 plus 5 is going to give us 8. So we're left with f of -1 equals 8. So what that says is when you plug -1 into your function machine, your output will be 8. Awesome. Letter C is a little bit spicier. There's a little bit more happening, but this is where it gets fun. We want to evaluate f of 3 and then plus 4, right? So we are going to do this first. It says evaluate f of 3. So we're not doing anything with that 3 and 4 together right now. All we're doing is we're saying, okay, let's take f of 3, evaluate it, get the output, now add 4 more to it, okay? So we're going to do this first. So we're going to say, okay, f of 3. We're going to go to our function. Wherever we see an x, we're going to substitute 3 in. -3 times 3 is -9. -9 plus 5 is -4. So f of 3 is -4. So now I'm going to take out that f of 3, and I'm ultimately going to replace this entire thing in that box, I'm going to replace it with -4, and then I'm going to bring over plus 4, and I'm going to add those two things together. -4 plus 4 is 0. So what we get is that when we evaluate f of 3, we get -4, and then we're going to say plus 4 to it. It gives us 0. So our final answer here should actually be 0. Okay, let's move down. We're going to spice it up a little bit with a little bit more of a complicated function, but that just makes it all the more fun. So looking at this example, we have f of x, and we have 2 places for that x. We have a quadratic, so we have 2x squared minus 4x plus 3. So the deal here is that you have to substitute in everywhere. Wherever you see an x, you're going to plug in that input. So for this first letter, A, we are going to plug -5 in for all of the places that we see an x. So that's going to be f of -5 equals, we keep the 2, then we're going to put -5 quantity squared minus 4 parenthesis -5 plus 3. Once you substitute it in, you're really just dealing with that right-hand side and simplifying, condensing that right-hand side. You're not doing too much with that left-hand side. You're keeping it f of -5, okay? And so here I just want to go over our order of operations, making sure here you're not doing 2 times -5 first. You're actually doing -5 squared first. So we're going to take care of our exponent. -5 squared, please make sure if you're using your calculator, you put that in the parentheses. So you should get positive 25. If you just punch -5 squared with no parentheses, your calculator is going to spit back negative 25 because it's going to do its own order of operations. Okay? I'm going to clean this up. -4 times -5, a negative times a negative is a positive 20. And then now I have a little bit more multiplication. 2 times 25 is 50. 50 plus 20 plus 3. That gives me 73. So what that says is that my input is -5. When I plug -5 in for this function, the output that it will spit back is 73. So if I have a graph of this function, the ordered pair -5, 73 will lie on your graph, okay? And so that's the first one. The second one is a little bit spicier. As you can see, there's a 2 in front. And so if I just gave you this, and I ask you how is 2, wait, let me move that so it's not in the way, sorry. If I just gave you this, 2x, and I said, okay, how is that 2 and that x connected? You'd say, oh, it's saying 2 times x. And so I don't want you to think anything crazy is happening with this letter B. All it's saying is that you have 2 times f of 3, right? So we're going to evaluate f of 3. We do that first, get rid of that function notation, get it to be a number. We're going to take our answer and multiply it by 2. So let's go here, f of 3. And one thing I was going to say is I would double check with your teacher, but as long as they're okay with you typing it all in your calculator in one clean swoop to get that output, and they don't want you to show every single step, you can enter that in your calculator, but that's up to your teacher's discretion. So don't just go and do that. I would make sure they're okay. They might want to see that you can do your PEMDAS order of operations. So remember, we're doing 3 squared first. That will give us 9. 2 times 9 will give us 18. I'm going to do the -4 times 3 will give us -12. So I don't put double negative. I'm just putting -12, okay? 18 minus 12 is 6, and 6 plus 3 is 9. So f of 3 is equal to 9. So now what I can do is I can say, okay, instead of putting 2 times f of 3 there, I'm just going to substitute 2 times 9. I'm going to take out that f of 3 and plug in that 9. And 2 times 9 gives us 18. So when we evaluate f of 3 and then we multiply by 2, we get 18. So that's just a little taste, a little sprinkle of evaluating functions. You can make this as elaborate as you wish or as simple as you wish, really. Some helpful hints is that x is always our input, and when we substitute that x value in, it yields us our output, which we call that f of x. F of x is really just y in its Halloween costume. I'm moving right on to the next bullet. It just merges nicely. Once you do that substitution, so I have so many kids that are awesome at doing that substitution, but where they get jumbled is in that simplifying. So, and it's not even that they don't know their PEMDAS, it's really sometimes when they're using their calculators and they're mistyping things. So like I said, when you are squaring a negative, you need those parentheses around, you need to do parenthesis -5, parenthesis, and then squared. Knowing a negative times a positive is a negative, but a negative times a negative is a positive. Knowing all of those little things, and so just make sure you work carefully and slowly. The hard part is that substitution, but then don't think, okay, I could just throw it away and move really quick. Work carefully and slowly so you don't throw away that hard part of that doing that substitution. You can do it. PEMDAS if needed. So what I did was I left you with 6 problems. For example, number 4, we did not touch on something like that, but just a friendly reminder, I'll just kind of give you a little hint here. You're going to evaluate f of 3, -3, sorry, evaluate f of -3, work it down, get an answer. Evaluate f of 10, work that down, get an answer. Then take your 2 answers and subtract them. So you're basically saying, okay, let me get a number for this, and let me substitute that number in. Then let me get a number for this, and let me substitute that number in, and then let me subtract those two answers. I do also want to point out that there are 3 functions there, and that's not to confuse you, that's not to make your life hard. It really was for simplicity so that we could fit the directions all in one line. So for number 1, when it is asking you for f, you're going to use the f of x function. Ignore g of x, ignore h of x. For number 2, it's asking for g of 2, so you're going to use the g of x function for number 2. Ignore the f, ignore the h, and so on and so forth. It's just kind of giving you 3 functions all in one line instead of rewriting it for every single problem, okay? So as always, just a reminder, if you need anything, the answer keys to this you try or a video to help get you through some of those trickier ones, that is in the details below. We are going to wrap up with lesson 7 in our functions topic before we move on to our 4th topic. And so please follow along, like, comment, and subscribe, all of those good things. Get the word out that I can help you with your math if you're a little bit stuck, and hopefully you find this helpful. Please let me know so I can morph my videos in a way to be more beneficial to all of you. So thank you for your hard work and keep it up.